Okay guys, we're going to start notes over the unit circle. So basically what happens with the unit circles, we're going to think of a circle on kind of the x and the y axis. So here's a circle. And we're going to have all these points on the unit circle that represents angles from this vertex right here. And remember we talked about last time that the initial side is on the positive x-axis side. And so we will create an angle like this that's on the unit circle. Well, when you create that angle, what I want you to think about is this ordered pair that's right here and how we get that ordered pair. So it's some x and y value. And if you notice, if we draw a line that's perpendicular to the x-axis, you've created a right triangle. The distance from, let me change this pin color. The distance from here to here is the x value that matches this x value in the ordered pair. And the distance from here to here is the y value that matches this y value in the ordered pair. So you have a right triangle created in there. And we have the fact that it's a unit circle means that your radius is 1 all the way around that unit circle. Okay, so also I want you to remember that when we did geometry, we learned trig, and we learned that the sine of theta was the opposite side over the hypotenuse. We learned that the cosine of theta was the adjacent over the hypotenuse. Oops, I don't know why I wrote that, sorry. The adjacent over the hypotenuse. And the tangent of theta was the opposite over adjacent. So for this reference angle right here, theta, the reference angle is always formed by the origin right there, the positive or the closest x-axis and the terminal side of that angle. So because we're doing trig, we're trying to, and we're using this unit circle, the sine is opposite over hypotenuse. So in this triangle over here, the opposite side to that angle would be y. The hypotenuse is 1, which is the radius, so that's why they just get the y value. So when you have the ordered pair on this circle, this y value is the same thing as sine. Cosine is the adjacent over the hypotenuse. So on this picture over here, the adjacent side is x and the hypotenuse is 1, and so that's where they get the x value. When they do tangent, that's opposite over adjacent. So the opposite side is y, the adjacent side is x. And then cosecant is the reciprocal of sine. So basically cosecant is the same thing as 1 over sine. And so whatever this fraction is or number is, the reciprocal of it will be the cosecant. Secant is the reciprocal of cosine. So it's the same thing as 1 over cosine. And then cotangent's the reciprocal of tangent, so it's the same thing as 1 over tangent. So basically, I mean, you can see here, it's just that fraction flipped because they're reciprocals. All right, let's see how this works. Okay, so on this particular example, we have an ordered pair that's going to be on our unit circle. So the x value is square root of 2 over 4. The y value is square root of 14 over 4. And so that's a point on your unit circle. So you're just kind of envisioning a unit circle. I'm not drawing that very well. And so that's a point on the circle. So right here is your radius. So you could create a right triangle right here where this x value is the square root of 2 over 4. The y value is the square root of 14 over 4. And then because it's on the unit circle, we know the radius is 1. And if I did the Pythagorean theorem, I would be able to figure that out. So it wants us to figure out all of these trig functions right here. We have an ordered pair for that. As long as that's the ordered pair on the unit circle, we talked about how the cosine was the x value and the sine was the y value. So I'm going to write that here. Cosine is the x value and sine is the y value. So when they ask you for the sine of t, it's just going to be the square root of 14 over 4. And that's because whenever you do the sine of t, you're doing the opposite from this angle right here, which I probably should label with t since that's the name we called it. The opposite side is this side. The hypotenuse is the 1. So you're doing opposite over hypotenuse, and that's where we get that, that value for sine. Okay, cosine is the x value, so cosine of t would be the square root of 2 over 4. Tangent of t would be opposite over adjacent, or we talked about how it was y over x, and so it's going to be technically square root of 14 over 4 over the square root of 2 over 4. And then I'm going to simplify that. So square root of 14 over 4 divided by square root of 2 over 4. That, using our rules for multiplying fractions, or dividing fractions, we would say square root of 14 over 4 times 4 over square root of 2. So those cancel. And then we're left with square root of 14 over square root of 2, which is the same thing as square root of 7. Because you can just divide those numbers since they're both under the same radical. So tangent is the same thing as square root of 7. All right, cosecant is the reciprocal of sine. So you just have to flip that fraction. It's just 4 over the square root of 14. Now we're supposed to rationalize it. We're supposed to make sure that the denominator doesn't have a radical in it. So we would multiply it by the number 1 just to keep it the same fraction, but make it look the way we want it to look. So multiplying that straight across, we get 4 square root of 14 over 14. Multiplying a radical by itself means that it's just going to undo the radical. So then that simplifies to be, if you'll notice right here, we've got 4 and 14. Those simplify to be 2 square root of 14 over 7. All right, secant of t, that equals 4 over the square root of 2. You'll rationalize it by multiplying the square root of 2 over square root of 2. So that becomes 4 square root of 2 over 2, which simplifies to be 2 square root of 2. And then the cotangent of t, we ended up with this for tangent, so it's the reciprocal of that. So it'll be 1 over square root of 7. Again, we need to rationalize it, so we'll multiply it by square root of 7 over square root of 7 to be square root of 7 over 7. All right, so that's our 6 trig functions. All right, another example. This time we're doing a negative 1/2 for our x value and a positive square root of 3 over 2 for the y value. So right here's our point. We're going to draw that right triangle. We always draw this leg here perpendicular to the x-axis. So this value is square root of 3 over 2 for the y side of that, or the opposite side of this angle. And here's our t right here. The x value matches this negative 1/2 down here. So now we're going to do our 6 trig functions. So sine of t will be the y value of that ordered pair, so square root of 3 over 2, because again our radius is 1 and we're doing the opposite over the hypotenuse. Cosine of t is the x value, so it'll be a negative 1/2. Tangent of t equals opposite over adjacent, or it would be the y over the x, and so it'll be square root of 3 over 2 over a negative 1/2. Each time you do this, whenever you work this out, it ends up just being, the 2's will cancel out. So you'll end up with the square root of 3 over negative 1, or just negative square root of 3. And then cosecant of t is the reciprocal of the sine, so it'll be 2 over square root of 3, which when you rationalize it, it ends up being 2 square root of 3 over 3. Secant of t will be the reciprocal of the cosine, so negative 2 over 1, or just negative 2. And then cotangent of t will equal, this is I'm basically flipping this fraction right here. So it'll be a negative 1 over square root of 3, which we need to rationalize. We're just not allowed to have a radical in the denominator. So that gives me a negative square root of 3 over 3. Alrighty. Okay, reading through this, in mathematics, a unit circle is a circle with a radius of 1, and we frequently, especially in trigonometry, use the unit circle or the unit circle is a circle of radius 1 centered at the origin 0, 0. The unit circle is a mathematical tool for making the use of angles and trigonometric functions easier. By understanding and memorizing the unit circle, we are able to breeze through otherwise calculation-heavy problems and make our lives a whole lot easier. So for any angle t, we can label the intersection of its sides at the unit circle by its coordinates x, y, and the coordinates of x and y will be the outputs of the trigonometric function. So this means that when you do it, the x will equal the cosine. Basically, you have an ordered pair, x, y. The x will be the cosine of the angle, and the y will be the sine of the angle. And like we said a while ago, the tangent of the angle is going to be y over x. So technically, it's going to be the sine value over the cosine value whenever you are on the unit circle. So let's look at this a little bit better. Okay, so this is like the first quadrant of the unit circle. I mean, we've got our unit circle that looks something like this. And what we're kind of focusing on right here is this part of it. So just the first quadrant. Whenever you're doing the unit circle, you have 4 quadrants. Oops, I did not mean to write with that, sorry. 4 quadrants. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We always start right here on the positive x-axis. So that's going to be where our 0 degrees is. And then our next set of degrees will be 30, and then 45, and then 60, and then 90 degrees. We talked about on the previous notes how to get radians. This is just 0 pi in radians. Remember, pi is the same thing as 180. So like right here, this is 0, this is 90, this is 180, this is 270, and then in radians, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi after you go full circle. So pi is the same thing as 180. That means that pi over 6 is 30 degrees, pi over 4 is 45 degrees, and pi over 3 is 60 degrees. I mean, it's like you're thinking about 180 divided by 6 to get that 30, or 180 divided by 4 to get 45, or 180 divided by 3 to get 60, or 180 divided by 2 to get 90. So because this is the unit circle, we know that this radius right here is 1, so this ordered pair will be 1, 0. This ordered pair up here at 90 degrees will be 0, 1. So then we're going to be using the 30, 60, 90, and the 45, 45, 90 to get the rest of the ordered pairs. So what I want you to remember is your 30, 60, 90 rules, which we have them drawn over here. The side across from 30 is A, the side across from 60 is square root of 3 times A, and the side across from your right angle is 2A. So if we let A be 1, this would be 1 here, this would be the square root of 3, and this would be 2. So that's what I want you to be thinking about for this unit circle. This side over here is 1 because it's across from 30. This is square root of 3, and this is 2. Now, we're on the unit circle, which means our radius, that would be the hypotenuse of these right triangles, is always 1. So if I wanted to make that radius 1, I need to divide everything by 2. So that would become 2 over 2. This would become 1/2, and this would become the square root of 3 over 2. So when we do when I think about, this being that 30-degree angle right there, right here's the 30 degrees, the x value of that will be the square root of 3 over 2, and the y value will be 1/2. Okay, so when we do the 60-degree angle up there, it's the same triangle basically, it's just kind of using a different reference angle. So 60, the side across from it is square root of 3. The side across from 30 is 1. The side across from the right angle is 2. We want it to be the unit circle, so our radius needs to be 1, which means we need to divide everything by 2. So the x value of that right triangle right there, the x value is 1/2, and the y value is square root of 3 over 2. Okay, then whenever you do a 45, 45, 90 triangle, you're using these rules, which for some reason that A didn't print out there. but the side across from 45 is A, the side across from 45 is A, and the side across from your right angle is the square root of 2A. So if we let all of those A's be 1, this is what we're looking at. So on a 45, 45, 90. The side across from 45 is 1, the side across from 45 is 1, and the side across from your right angle is the square root of 2. We want it to be on the unit circle, so we're going to divide everything by the square root of 2 this time. That way the radius will be 1. Now we're supposed to rationalize this, so we'd multiply it by the square root of 2 over square root of 2, which gives me square root of 2 over 2. So our x value ends up being square root of 2 over 2, and my y value is also square root of 2 over 2. And that works for this 45, 90 triangle. So these are the ordered pairs that are actually on your unit circle. All right. So you're going to need to memorize all of these values on this unit circle right here. So things to think about or to consider on this unit circle is, this is in the quadrant where right here, these x's and these y's, everything, the x's are positive and the y's are positive. So on your ordered pair, the x's and the y's are positive for each of those numbers on those ordered pairs. So that's one thing to consider. Another thing to consider is in this quadrant, the x's are negative and the y's are positive. So for each of these ordered pairs, the x's are negative and the y's are positive. In this quadrant, we've got the x's are negative and the y's are negative, so that matches each of these ordered pairs. In this quadrant, the y's are negative and the x's are positive, so that matches how our ordered pairs look. So just those are some things to consider. Some other things to consider is if you were to reflect over this y-axis right here, like this point and this point, they're equal distance to that y-axis, so that's a reflection. Well, those ordered pairs, they match each other. The only thing that's different is the sign of the x's have changed. Here, these ordered pairs match each other. Again, the only thing that's different is their signs have changed. Another thing to consider is we could be reflecting over the x-axis. The x-axis, this point, is the same distance from the x-axis as this point right here. So these points right here are the same. The only thing that's different is the sign of the y. So they're just reflections over that x-axis. Okay. And that goes, for this point to this point, reflected over the y-axis. So the sign of the x's change and so forth. Some other things to think about is this right here is a 30-degree angle from that 0 degrees, that 0 degrees right there. And this is 30 degrees away from that 0 degrees. Well, the angles that are 30 degrees away from the x-axis, they have the same ordered pair on either side. It's just, what the signs of their x's and y's are in those quadrants. Like this angle right here, it's 45 degrees from this x-axis. This angle right here is 45 degrees away from that same x-axis. So their ordered pairs match each other. The only thing that's different is the signs of the x's and the y's. So that's going to work for all 30, 60, 90, and all 45, 45, 90s. All right. Another thing to think about is, for this 30-degree angle right here, the x value from here to here is further away than this y value right here. So the x gets the bigger number, the square root of 3, and the y gets the 1/2, or the 1 on top. Versus this 60-degree angle right here, those ordered pairs match right there. The only thing that's different is they're flipped. Here, the x value is, closer, and the y value is further away. So that's why those numbers are switched. So something to just think about. All of the 45-degree angle ones, the ones in the middle right there, so this one right here, this one right here, this one right here, and this one right here, they all have the square root of 2 over 2. So those are the same in each of those. All right, so there's just different ways to memorize this, and I'm trying to give you some hints. And you just kind of have to think through what would work best for you. Okay, next we need to talk about reference angles. So The value of a trigonometric function of angles greater than 90 degrees or less than 0 can be determined from their corresponding acute angles, and they're called reference angles. So again, a reference angle is the acute angle formed by the terminal side and the horizontal axis. And what I want you to think about is the closest x-axis. So if you're in the first quadrant, that reference angle is easy because it is an acute angle. So this angle right here is your reference angle. So you don't really have to think about that one too hard. But when you're in the second quadrant over here, this is your initial side, this is your terminal side. That's an obtuse angle. So your reference angle has to be formed by this terminal side right here and the closest x-axis. So this would be my reference angle right there. And so the way we're going to get that, you're going to think about using the closest x-axis and that terminal side. To get it, you're going to either take theta equals pi minus theta. So, let me do an example. Let's say we do a 120 degree angle. Right over here is pi, which is 180 degrees. So the difference between 180 and 120 is 60 degrees right there. So 60 degrees is my reference angle. And I got that by doing 180 minus 120. If it had been in radians, you would have just been subtracting it from pi instead of the 180. When you're in the third quadrant and you're using your reference angle, the reference angle is formed by this terminal side and the closest x-axis. So you've gone all the way over here to pi, and then you've gone a little bit more. Well, that little bit more happens to be your reference angle. So the way we'll get that is we'll take theta minus 180 degrees, or theta minus pi, depending on degrees or radians. So an example, and let's say we drew an angle way over here. And let's say that angle is like, 210. So 210 degrees, this is 180 degrees. We've got another 30 degrees past that 180, so my reference angle is 30 degrees there. And again, we could have gotten that by doing 210 minus 180. Okay, let's do another example in quadrant 4. So over here, you're using this as your closest x-axis. This is your terminal side, so this will be your reference angle. And we can get that by doing 360 minus theta or 2 pi minus theta. So for example, if I had 300 degrees, and right here is 360. So the way we can get this reference angle right here, we would just subtract those, so it would be 60 degrees, because we would do 360 minus 300. All right, so, I just accidentally did this next problem. So the reference angle for 300, because it's drawn over here, we would do, and this is 360 and this is 300. We need to go another 60 degrees to get a full circle. So 60 degrees is my reference angle. And I get that by doing 360 minus 300. This time my angle that they gave me is in radians. And so we need to be thinking about in terms of radians. So right here is pi. Pi as a decimal is 3.14. Half of that would be up here at about 1.57. So 2.3 is going to be about right here. So that's the angle 2.3. So if I want to know what this reference angle is, which would be formed by the terminal side and the closest x-axis, I'm going to do pi minus that 2.3. And that would be my reference angle. On the next one, you're doing a negative 135 degrees. So this time we have to go clockwise because it's a negative angle. And so we'll go this direction. So this is a negative 135 degrees. Right here would be a negative 180 going in the clockwise direction. So I'm looking for this reference angle right here. So I'm going to do 180 minus 135 to get that reference angle is 45. Every reference angle is a positive angle, and it has to be acute as well. So that reference angle is 45 degrees. So why we care about reference angles is that basically whenever you go back to your unit circle, let me back up a little bit. when you look at your unit circle, this angle right here is a reference angle of 30 degrees versus this angle right here, also a reference angle of 30 degrees because it's this 360 minus that 330. So the angle right here, this ordered pair, corresponds to that 30-degree ordered pair. So really all you have to remember for the unit circle is this quadrant right here, which is why we drew that on that other page, because all of these reference angles right here are going to correspond to these angles over here. They're reference angles. So for example, this 150 degrees has a reference angle of 30 degrees. So it's going to use those same ordered pairs that the 30-degree angle uses over here. All right, going back over here to example 4. This is wanting you to think about what point is symmetric with respect to the y-axis of the point square root of 3 over 2, negative 1/2. Well, that point is located over here somewhere where the x value is square root of 3 over 2 and the y value is a negative 1/2. So a point that's symmetric with the y-axis, here's your y-axis. Symmetric means it has to be the same distance on the other side. So a point symmetric to it would be about right here, and it's going to have the same y value of a negative 1/2, but it's going to have an x value of a negative square root of 3 over 2. So a symmetric point would be a negative square root of 3 over 2, and the y value would be a negative 1/2. Okay, this is asking what radians have the same reference angle as pi over 3, which remember pi over 3 is the same thing as 60 degrees, if that helps you kind of visualize it. Well, this is where pi over 3 is right here, and its reference angle is pi over 3. Anytime we ask you for a reference angle, if we give it to you in radians, you need to give it back to me in radians. Right here would be pi. Well, pi is the same thing as 3 pi over 3. I am not writing that very well, am I? 3 pi over 3. So 2 pi over 3 is going to be right here. And its reference angle is that pi over 3. Over here would have a reference angle of pi over 3. It's pi over 3 past that, which would be 4 pi over 3. And right here is going to be pi over 3 away from 360 or 2 pi. And 2 pi is the same thing as 6 pi over 3. So this would be 5 pi over 3. So my angles that have the same reference angle as pi over 3 would be 2 pi over 3, 4 pi over 3, and 5 pi over 3. So what I want you to notice is that every one of these that have a reference angle of pi over 3, they have a pi over 3 in their, in the name of their angle. So another angle that would have a reference angle of pi over 3 is 11 pi over 3, or 71 pi over 3. So as long as it's got a pi over 3 in it, it has a pi over 3 reference angle, or a 60-degree reference angle. Okay. Next, what degrees have the same reference angle as 45? I don't know if I can make this a little bigger. Okay, reference angle, same reference angle as 45. Let's just draw that over here. So here's a 45-degree reference angle. We want a reference angle here that's 45, a reference angle here that's 45, and a reference angle here that's 45. Remembering that this is 180 right here, this is 360 right here. So 180 minus that 45 would be 135. 180 plus the 45 would be 225. This 360 right here minus the 45 would be 315. So degrees have the same reference angle as 45 degrees would be 135 degrees, 225, and 315. Okay, next this is asking, let me make this smaller. Okay, this is asking if point XY is a point on the unit circle in the quadrant 3. So we have a picture here, and we know X is a negative 1/2, so we go out here a negative 1/2. And if you think about this triangle right here, and this is a unit circle, so this is going to be 1 right here. This side over here would, you could use the Pythagorean theorem to figure this out. We know the y value is going to be negative, but basically what you should see is that this hypotenuse is twice as big as this side over here. So this is using those 30, 60, 90 rules, where this was your A, this was your 2A, and this was your A times the square root of 3 side. So this is going to be square root of, well, I just kind of wrote over the negative. This is going to be the negative square root of 3. I cannot write that, sorry. Square root of 3 over 2. So my y value would be negative square root of 3 over 2. And by the way, this reference angle, because it's across from the square root of 3 over 2 side, that tells me this reference angle right here would be 60 degrees or pi over 3. So I know that this angle right here will be 60 degrees past this 180, which makes it 240 degrees. Or you could say, you know, if this were in radians, this would be pi, which is the same thing as 3 pi over 3, and 60 degrees is pi over 3, so you've got another pi over 3 past that, so it's also 4 pi over 3. All right. Okay, on this one, they want us to think about the angle 5 pi over 6, so let's draw that first. All right, I always go on my unit circle and remember where pi is. Get it with the same denominator as what the angle is that they've given to me. That's the same thing as 6 pi over 6. So halfway, which would be right here, would be 3 pi over 6. So 5 pi over 6 has to be right here. That would be this angle. So this reference angle that's right here would be 6 pi over 6 minus 5 pi over 6, which happens to be pi over 6. So I know my reference angle is pi over 6. And now they want me to figure out the ordered pair that would match this on the unit circle. So remembering, you know, on your unit circle, the ordered pair x, y, the x value is your cosine and your y value is your sine. So remembering, you know, pi over 6 is the same thing as a 30-degree angle. If I draw that triangle, this side right here is my adjacent side, which is going to be across from that 60-degree angle, so it'll be square root of 3. In this quadrant, let me make that better. In this quadrant, it's negative. The side across from 30 would be 1, and the side across from my right angle is 2. So if I did the trig functions, cosine is adjacent over hypotenuse, so it will end up being a negative square root of 3 over 2. And then the sine is opposite over hypotenuse, so it's going to be 1/2. And then we're in that second quadrant right there, where the x's are negative and the y's are positive. So I should notice that in my ordered pair, my x is negative and my y is positive. All right, let's do 4 pi over 3. So again, this is pi, which is the same thing as 3 pi over 3. So this is a halfway, so it's 1.5 pi over 3. And this is, so we're counting for each quadrant 1.5 pi over 3, so this will be 4.5 pi over 3. And then over here will be 6 pi over 3. So 4 pi over 3 is going to be in this quadrant right here. So we're talking about this angle. If I go ahead and I draw my right triangle, this reference angle, if this is 4 pi over 3, we would get the reference angle as 4 pi over 3 minus 3 pi over 3, which is pi over 3. Or you should be thinking of a 60 degree reference angle. So, let me make that better, sorry. So this angle right here is 60. The side across from 60 is square root of 3. In this quadrant, it's negative. Side across from 30 is a negative 1 in this quadrant. And this is 2. So sine is opposite over hypotenuse, which would be a negative square root of 3 over 2. Cosine is adjacent over hypotenuse, so it's going to be a negative 1/2. Tangent is opposite over adjacent, so it's going to be a negative square root of 3 over over negative 1, which is just square root of 3. Cosecant is the reciprocal of sine, so it'll be hypotenuse over opposite, so it'll be 2 over negative square root of 3, which we need to rationalize. So it'll be a negative 2 square root of 3 over 3. secant's a reciprocal of cosine, so a -2/1 or just -2. And then cotangent's a reciprocal of tangent. I'm going to flip this fraction, so it'll be 1/√3, which we need to rationalize. So it'll be √3/3. So one thing I want you to think about is which trig functions are positive in which quadrants. So we've got our 4 quadrants. Everything's going to be positive in this quadrant, so all of them are positive here. The only trig functions that are going to be positive in the second quadrant are the ones that use the y's. And if you'll remember, sine uses the y. It's technically the opposite over the hypotenuse, which is y/r. Cosine uses the x's, so it's x/r. And then tangent uses the y, it's y/x. So the sine is going to be positive anywhere where the y values are positive. So all of them are positive in the first quadrant. Sine will be positive in the second quadrant. Tangent's going to be positive here, and that's because it uses the y's and the x's. And so if you do a negative over a negative, then it'll end up being positive. And then cosine will be positive here because it uses the x's. So we have an acronym to help you remember it. And all students take calculus is a way to help you remember that. And so normally I'll just draw it like this, and I'll say all students take calculus to help me remember which trig functions are positive in each quadrant.